Hello, Math Studies students. Today we'll be continuing our lesson on arithmetic sequences, essentially picking up where we left off and looking at some more advanced applications of using the concept of arithmetic sequences and some of its properties. So for this example, we are trying to find an unknown value k, given that 3k plus 1, k, and -3 are consecutive terms of an arithmetic sequence. So a couple things we need to talk about here. First and foremost, what does it mean to be consecutive? And so consecutive is next to each other. If we look back at the example that we had looked at on the previous video where we had 2, 5, 8, 11, so on and so forth, those are all consecutive. They follow one another in the pattern. We're adding 3 every time, and so I've got a 2, and then I've got a 5, and then I've got an 8. Those are the first 3 terms. They're all in order. Now, if I went from 2 to 8, those are not consecutive because they're jumping around. But the consecutive terms are always right next to each other. And the thing that we know about consecutive numbers, or consecutive terms, even though they're not the same value, I can get a common value if it's part of an arithmetic sequence. And the way we do that is we show that we have a common difference. So if I take, for example, 5, this term right here, the second one, and I subtract the previous term, 2, that would be the exact same thing as if I start with the third term, 8, and subtract its previous term of 5. Because both of those are going to show that the common difference, or the thing that was being added on, was 3. And 3 is equal to 3. I could do the same thing even with the next term here, 11 minus 8, as I work backwards, is also going to give us that value of 3. And so any pair of consecutive terms, if I subtract backwards with them, I get a common difference. Well, that's going to help us out now in this problem, because we have 3 terms, except the problem is they all, or at least 2 out of 3 of them, involve variables. So the first term we have is 3k plus 1. Now, once we know what k is, we'll multiply by 3 and add 1, and we'll have some number. And that's the first term that I have here. It might not be the first term in the sequence, but it's the first in this set of 3. The next term I have is k. And the term after that I have is -3. Well, as we just showed, we can say that all of these should have a common difference if they're truly part of an arithmetic sequence. So all I have to do is subtract backwards. So I'm going to start with my second term, which is k, and I'm going to subtract the term that came before it, which is all of this stuff, 3k plus 1. So again, just like we've done over here, and I'm going to write it again. We had 2, 5, 8, 11. If I just subtract backwards, I'm getting a 3 here. If I subtract backwards, I'm getting a 3 here. If I subtract backwards, I'm getting a 3 here. I'm always getting that same common difference. On this problem, I don't know what the common difference is, but I know if I subtract backwards starting on this second term, k, it should be equal to the same thing as if I start with my third term, -3, and again subtract backwards my second term, which was k. So now we have an algebraic equation. It's got some parentheses and it's got variables on both sides, so a little bit of tedious work to do here. The first thing I'm going to do is get rid of these parentheses. And so I need to distribute anything that's in front of it. And the only thing that's in front of it is this negative sign, or essentially like a -1 is sort of implied there. That sort of looks like an equal, so let me clean that up. So I have -1 that's going to distribute to each and every one of these things. So I'll end up with k minus 3k minus 1 is equal to -3 minus k. Now I'm going to combine like terms. I have a bunch of k's here, and so a k minus a 3k would give me -2k, because I have more negatives than positive. And then I have -3 minus k over here. Let's get all of our k's to one side. So I'm going to add k over here. And I'm left with -3 on the right side. On the left side, you'll notice that these two terms, one's negative, -2k, and the other one is positive k, but the signs are different, so I'm going to subtract. 2 minus 1 gives me just 1k, but I had more negatives than positives, so I'd have -k minus 1. My last step, and I'm going to have to do my work over here, is to get k all alone. So let me copy over what I had. -k minus 1 equals -3. Add the 1 to both sides, and I end up with -k is equal to -2. Now, I don't want -k, I want just k, so I can either just cancel out the negatives from both sides or divide both sides by a -1. The 1 doesn't change anything, but the negative will cancel out the negative signs that we had, and so k is equal to 2. And that's my final answer. Now, how can I be sure it's correct? I can go back and plug it in. So if I plug it in, I now will know my three terms. The first term that I had here, 3k plus 1, well, that will be 3 times my k, which I now know is 2 plus 1, which gives me 7. And then my second term was just k, so that is 2. And my third term was negative 3. So now I should be able to subtract backwards and show the common difference. And in fact, I could find what it is. Now, the question didn't ask me to do this, but I can still go ahead and do it. So if I take this second term and subtract what we had first, 2 minus 7 gives me negative 5. And it's totally fine to have a negative difference. Clean that up a little bit. And then I'm going to do the exact same thing with my negative 3, subtracting 2 from it. So negative 3 minus 2, and that also gives me negative 5. So right away, I know my common difference. It's negative 5. I know my value of k. It was 2. All right, moving on to our next example. On this problem, we're looking for our general term. If you remember from our previous lesson, our general term is essentially the formula that allows us to find any term in the sequence by plugging in our desired term number. It is an arithmetic sequence, so we know it has a common difference. And we also know u sub 3. And to refresh our memory, u sub 3 means the third term. So if I listed out all the numbers, the third number in the list would be 8. And the eighth number, or u sub 8, the eighth term, is going to be negative 17. So when I get a problem like this where I have a couple numbers that are not consecutive, that are sort of spread out, I try to draw a little picture. You might say, how do you draw a picture for a number list? Well, I just sort of do a fill in the blank. So I've got the first term, I don't know it. Second term, I don't know it. Third term, it's 8. Fourth, fifth, sixth, seventh, and eighth term, I know the eighth term, it is negative 17. So from here, I can start trying to make an equation up that'll help me decide how do I go from an 8 to a negative 17. Well, for an arithmetic sequence, how do we go from any term to the next term? And the way we do that is we add on our common difference. Unfortunately, I don't know what the common difference is. It's part of what we need to find here. So I can essentially say I'm going to add on one difference here to get from my third term to my fourth term. And then I'm going to add a difference on again to get to my fifth term, my sixth term, my seventh term, and then I would arrive at my eighth term. So how many common differences was that? Well, we had 1, 2, 3, 4, and 5. 5 common differences are being added on to the 8 to get my negative 17. So let's write an equation for that. 8 plus 5 differences, or 5d, is equal to my eighth term, which is negative 17. Now I'm just going to solve for d. I subtract 8 from both sides. I get 5d is equal to negative 25. Divide both sides by 5, and I get a common difference of negative 5, just like on our last problem, but totally by coincidence. So I can use that now to find out all of the other values. So all I have to do is just add on a negative 5 over and over again to get my fourth term, my fifth term, and so on and so forth. So 8 plus negative 5, which is the same thing as 8 minus 5, would get me a 3. And then if I subtracted 5 again, I would have negative 2. And if I subtracted 5 again, I would have negative 7. Subtracted 5 again, I would have negative 12. And subtracted 5 one more time, or added a negative 5, I would end up at negative 17. So everything's checking out so far. In order to write my general term, there's two things that I need. I need to have my common difference, which we already figured out, but I also need to have my first term, which we don't have yet. So I'm now going to work backwards. So if to move forward in my sequence, I was subtracting 5 every time, or adding a negative 5, now I'm essentially going to do the opposite of that and subtract the negative 5, or essentially just add 5. So to work backwards, if I add 5 to 8, I end up with 13. If I add 5 more to that, I end up with 18. So I now know that the first term of my sequence is actually 18. So we still haven't actually answered the question, which was, what is my general term? To do that, I'm going to write down my formula from last class. U sub n is equal to u sub 1 plus n minus 1 all times the common difference, d. And all we need to know is u sub 1 and d. What does u sub 1 stand for? That is our first term, which we now know is 18. So u sub n, our general term, our nth term, is equal to 18 plus n minus 1 times my common difference. Well, our common difference is over here. It is negative 5. We found that earlier. And voila, I now have a formula for u sub n where I've plugged in u sub 1, my first term, and d, my common difference. I don't really love the way it looks. It's not really simplified. So I can go ahead and do that, and that'll make it easier to move forward on this problem. But if you wanted to leave your answer like this, that would be acceptable. So I'm going to distribute this negative 5 here. So I end up with u sub n is equal to 18 minus 5n plus 5. Now, where did the plus 5 come from? Well, the negative 1 and the negative 5 multiply together to become a positive. And now I can combine terms. I have an 18 and a 5. So u sub n is equal to 23 minus 5n. Or you could write negative 5n plus 23. So I'm totally done with this problem, but I'd like to double check it just to make sure it's true. And so let's pick a number that I already know the answer to. So the 8th term we already knew was negative 17. Well, let's see if it works. If I plug an 8 in for n, here and here, do I end up with negative 17? So let's put that work right over here. And so I'm going to have u sub n, but our n that we're looking for is 8, is equal to 23 minus 5 times n. And what is n? We just said it was 8. We're trying to figure out the 8th term. Why are we trying to figure out the 8th term? Because we already know it. And if we get the right answer of negative 17, that means our formula is correct. So now I have u sub 8 is equal to 23 minus 40. Well, we're subtracting two numbers. 40 minus 23 gives me 17. However, it was the one being subtracted. The bigger one was negative, essentially. So we have to have a negative answer here. So u sub 8 equals negative 17, which is exactly what we were expecting to have. Just to recap, again, the actual answer to this problem was right here, or you could have even put this one down. But to be able to check our work and be able to use this moving forward is a really valuable thing. So those were a few extra applications of arithmetic sequences and all the formulas that we had for that. Until next time.